Hello everyone, welcome to Module 5, Part 6. In this section, we are going to check the integration of other elements. We have already seen the integration of IC or the integrated circuits. Now, we will check how the circuit elements such as resistors, capacitors and inductors are being implemented on a single chip. Integrated circuits are much cheaper to make than the resistors and the capacitors. First we'll check about the diode, how to integrate it on the IC. It is simple to build a PN junction diode in monolithic circuits. Since many circuits are included in a monolithic circuit, no special diffusion step is required in a diode fabrication. Transistors can be used as a diode by using emitter junction as diode and shorting the collector base. So we know that we have three terminals, emitter, base and collector. We can use the emitter junction as the diode and we can short the collector and the base junction. So if we have a transistor like this, so this is the emitter junction over here and the collector junction, this is emitter and the base junction. So we can use, so we all know that this is the diode like this is the anode and the cathode. So we can use this junction as a diode by shorting these two. If we short these two, so this will be a diode now with anode and cathode. Next are the resistors. Diffuse resistors can be obtained in the monolithic circuits by using shallow junctions, which is in forming the transistor regions. Resistors are made up of thin p-type layer within one n-type layers. Resistors can be isolated from the rest of the circuit by proper biasing of the surrounding material. The resistance of the channel depends on its length, width, depth of the implant and resistivity of the implanted material. So the resistance of the channel R is given as rho L divided by Wt, where rho is the resistivity of the diffused region. So this rho value will be given. L is the length of the channel, W is the width of the channel, T is the thickness of the layer. To reduce the amount of space used for resistance, it is necessary to obtain the surface layers having large sheet resistance. So the sheet resistance is nothing but the measure of resistance per square meter. The resistance is given as R equals to Rs into W by L, where R is the sheet resistance. So resistance can also be given in sheet resistance and even in resistivity, which we have seen in the previous equation. So sheet resistance is the measure of resistance per square meter. So if sheet resistance is given in the problem, the resistance can be calculated. Similarly, if the resistivity of the material is given, that is rho is given, then also we can find out the resistance. Next, moving on to the capacitor. Capacitor is important in integrated circuit. It stores charges for each bit of the information. This figure shows the one transistor DRAM cell. N-channel MOS transistor provides access to the adjacent MOS transistors. So the top plate over here is the polysilicon. This is the polysilicon. The bottom plate over here is the inversion charge by N plus region of the transistor. So this is the inversion charge. Over here the top plate is the polysilicon layer. Here the bit line and the word line refers to the row and column organization of the memory. Bit line is the row and the column line is the word line is the column organization of the memory. Since this is a one transistor DRAM cell, so the base layer is the P and the diffusion layer is the N plus. The capacitance C is given as epsilon L W by D. Epsilon is the constant which will be given, L is the length, W is the width of the channel and D is the thickness of the dielectric material. Moving on to the inductors. Inductors are hard to integrate on integrated circuit than the other circuit elements. Recently they have been used in many portable communication such as RF analog ICs. Inductors are built by spinal wound thin metal film on an IC. So these spinal patterns can be defined by photolithography and etching techniques. So it will be something like this. They are fabricated in this manner and it is defined in photolithography and etching techniques. Moving on to the contacts and interconnection. During metallization process, various regions of each circuit elements are connected and proper interconnection of each circuit element is made. Aluminum is the commonly used metal for integration on the silicon, and if the base material is gallium arsenide device, then gold is being used for interconnection. Silicide contacts and doped polysilicon contacts are commonly used in integrated circuits. Increased complexity and packaging density in ICs leads to the need of multi-layer metallization. So metallization is done on a multi-layer like this. So integration is done over here, then connection is done over here like this. So these are the metals, all these are the metals. So this is multi-layer integration. Metals can be aluminum or copper depending upon the heat each is subjected to. The multi-layer metals are incorporated with dielectric in between. The dielectric deposited are oxides, borophosphosilicate glass or nitrides. Borophosphosilicate glass is used for planarization. Planarization is required to prevent breaks in metals. The most important challenge in designing the interconnection is the RC time constant. This affects the speed and active power dissipation of the chip. As we all know, the resistance of the chip is given as rho L divided by Wt. It is also equal to Rs into L by W. The capacitance is given as epsilon Lw by D. Now the RC time constant is rho L divided by Wt into epsilon Lw divided by D, which is equal to, so this W and W get cancelled off. So what remains is rho epsilon L square by Td, which is equal to Rs, which is the sheet resistance, into epsilon into L square, the length of the channel, and D, which is the thickness of the intermetal dielectric. Now RC, or the resistance capacitance time constant, is given by this particular equation. So the RC time constant can be reduced by increasing the intermetal dielectric layer or the thickness of the intermetal dielectric layer, or having the low dielectric constant. Epsilon is the dielectric constant. During metallization step, appropriate points in the circuits are connected to relatively large pads to provide external contacts. So there are pads on the ICs so that the external contacts can be done. So just like this, we have a small chip, and over here there are pads on the sides. So these pads are used for external contacts. So this is all about how the elements such as diode, resistors, capacitors and inductors are integrated on a single chip. Thank you.